Thanks everybody for joining today for the chance to learn more about our chemical drainage system. Today we're going to cover our value proposition, how the chemical drainage works, some of the features, benefits, components, options, and choices you've got, do a summary, and just wrap up with the resource page. From our engineers and building owners, Zurn does provide a chemical drainage product offering of both polypropylene and PVDF for pipe and fittings. Unlike our competitors, however, we have one fitting for two different mechanical joining systems and one fusion system, so a combination fitting that helps reduce inventory carrying levels and also allows for additional job site flexibility, providing reliable leak-free joints for the purpose of disposing of chemical waste and keeping the water supply safe. If we look at the voice of the customers for the industries we serve, the owner needs a dependable, durable, low cost of ownership, lower cost to install and maintain for the life of the building that reduces minimum downtime and is easy to maintain. The engineer needs a dependable product that meets codes and compliance issues and is also durable, lasts the life of the building, and also providing a cost-effective solution. And whereas the contractor is going to look for something that's easy to install, easy to maintain, assembled, received on site in an easy fashion, and saves them labor and handling on the job site. One of the things I mentioned is we do offer different type piping, so you will see them represented there by the various colors. So black polypropylene for underground, the teal or aqua for above ground, which is a flame retardant polypropylene, and at the very top, the polyvinylidene fluoride or PVDF for your return air plenums. So as you do go up on that page and in the building, you do go also up in price. So that's one of the first questions we want to address is why not have one pipe, one solution for every application? Reason is cost. So if you look at the non-flame underground piping, which is black, it is going to be a straight polypropylene with just some black pigment in it, and that's going to be the lowest cost option. However, once you get above grade into the building and the walls, under cabinetry, you do require a flame retardant polypropylene for building and fire codes, and that's your aqua. That's about double the cost of the non-flame retardant because of the additional additives in there to create that UL94 V2 flame resistant rating. And then as you go up further into the plenums, you get to the PVDF, which is about 4 to 8 times the cost depending on the size of the flame retardant. So they are each cost effective for their application, but answering the question, why have the various materials? So if you look at the PVDF, it's actually a polyvinylidene fluoride, which is in the Teflon family. Everybody's familiar with Teflon as being the nonstick coating on a fry pan. Again, very chemical resistant. Again, with the PVDF, also very chemical resistant, very dense, hard. Again, used sparingly in those plenum areas where the option would be to wrap it and incur additional costs with like a fiberglass wrap, or reroute it, incurring costs of additional piping and labor, or if, in this case shown, go through the plenum but using the PVDF. So the next most common would be your flame retardant, which is in all your walls and above ground, and then your non-flame or black pipe would be used underground. You will notice that the fittings, even underground, are still the aqua color. So we do only offer 2 materials for the fittings, whether that's the flame retardant polypro or the PVDF, to match the pipe in the plenums. You also notice there that all those pipes do drain, whether it's from a floor drain or from the lavatory drain, and do the neutralization tank. The tanks are constructed of HDPE, which is high-density polyethylene, which is also a thermoplastic, which in the polyolefin family, and very similar in chemical resistance to polypropylene. But most tanks, barrels, containers are made out of HDPE. Important note there is that you cannot fuse or bond to that by heat. That is a mechanical joint only. Again, when you're looking at the pipe options, we do offer 3. Your non-flame or black, which is in your ground, shown in the middle section there, can be 10-foot or 20-foot lengths. We do stock both of those, and the idea with the 20-foot length is that it will reduce a coupling and therefore labor and get you to those longer runs that are typically featured under the ground. That is 1.5 through 2-inch sizes. The flame retardant polypropylene, also 1.5 through 6-inch in diameter, does come standard in 10-foot lengths. And then the PVDF is 1.5 through 4-inch. Again, most of that is above ground in plenums, and 4-inch is more than ample size to accommodate that requirement. And those are also 10-foot length. So that PVDF pipe does carry a UL 723 E84 flame and smoke resistant rating, whereas the flame retardant is a fire retardant to a UL 94 V2, and of course the black or non-flame retardant is not rated, again, which is for use underground. Let's talk about the joining methods now. And so the value add that Zurn offers is one of fitting can be used for any 3 of the joining systems shown here. So whether it's the traditional grooved mechanical connection, the labor-saving stab lock mechanical connection, or the fusion lock coil fusion heat joining method, the same fitting can be used, and it's just a different steel or insert that goes between the fitting and the pipe to make those various different type fitting connections. So the question is, which one do I use? And I can go through the typical installation there, but before I do, one notably missing joining method, which is typical for plastic pipe, is a glue or a solvent joint. So if you're familiar with or ever installed ABS or PVC, you know there's the purple primer and then the glue, the solvent weld that you put into the fitting with the dabber within the glue, and then the connection makes a chemical bond. Well, if you recall the title of our training today, it is chemical piping. So it's chemically resistant and therefore not able to be glued or joined by chemical process as other piping systems are. Therefore, that's why it's used for chemical resistant in draining of chemical waste. So let's talk about the mechanical joining system here first. Traditional grooving, there is a grooving tool that does put a groove into the pipe where the polyethylene seal will snap into place, and then tightening of the nut compresses that seal and creates your leak-free joint. That was our initial mechanical offering. We've come out with a stab lock a few years after our initial release, which is shown on the right-hand side there, which features a stainless steel grab ring. Just as it indicates, you put the polyethylene seal and grip ring into the fitting and stab the pipe in and tighten up the nut, and you've got your seal. So again, working on our lean theme of saving time during installation. The stab lock does not require that additional grooving be done to the pipe, which saves time. You also don't need an additional tool, and so you can install faster. The next joining method is a coil heat fusion or electrofusion. We call our fusion lock, which is a resistance wire in a polypropylene steel that heats up and creates a bond between polypropylene pipe with polypropylene, the polypropylene fitting. So it's a like-for-like material that heats up and will bond with heat. It's very much similar to the toaster wire when you're making breakfast. Electricity passes through, heats it up, and melts the polypropylene seal and bonding into the pipe and the fitting. Of course, all with the correct amount of amperage and wattage and current applied to it by use of the coil fusion machine. The fusion is only available for polypropylene. So that would be both for the flame retardant and the non-flame retardant options. PVDF is only available in either the mechanical or stab lock. So those are the mechanical and fusion joining methods. The question would be then, well, which one do I use, or what dictates the type of joining system? And I would say that most of it is by either engineering preference or local codes. And typically, if it's below ground, it's going to be fused, and if it's above ground or accessible, it would be mechanical. Now, that said, you can have mechanical below or you can have fused above, but it's probably an 80-20 rule or even higher than that, that your fusion is below ground, your mechanical is above ground if you've got access to it. I have 4 drains as well, so in a bigger commercial or industrial application where you might be working with chemicals, say in a food processing plant, you do need to capture that material that might be spilled onto the floors, and you do want to use a chemical resistant 4 drain. We do offer stainless steel drains. but in keeping with the polypropylene or PVDF, we also have those bodies here. On the right, you can see our FD4. We do show it with a sediment bucket, which would help capture any debris that might be on the floor if it's swept up or washed into that drain. And then the grate on the top is a polypropylene grate. You do see there are holes there for an optional funnel if it's used as a condensate, say, capture. Or the bottom grate is a ARE coated, which stands for acid resistant epoxy coated heavy duty cast iron grate. So if you're going to have any fork trucks going over it that are of heavy loading, you're going to want to go with the cast grate versus the plastic grate. It does also come with a trap primer option connection if you do choose to do that. This one does also have a clamping collar. You'll note any of the hardware you do use is also stainless steel when we're talking about chemical wasting systems. Just another floor sink we offer. This one is in the polypropylene with the aqua material. And this does come either a full grate, half grate, or quarter grate. Again, condensate is typically acidic, so if you've got any of those machines that are dispensing that, it'd be a great option to go with one of these type drains. So for our cleanouts, we actually utilize a coupling with a plug in it. We're shown here with a PVDF cleanout, and again, that would be in your either wall or floor for snaking the drain line out should there become a clog, or just access to it for inspection. Do come polypro and PVDF. So where does all the waste go once it is transported with the system, whether it's polypro or PVDF, down to the neutralization tank? The neutralization tanks range from 5-gallon to 3,000-gallon. We also have a point of use fixed cartridge system I'll talk about in a few slides. But the main purpose here is to collect all that waste and treat it before it is sent out to the municipal sewer. So again, these are filled with limestone chips. We do have some specifications on those coming up as well. What you've got shown here in the yellow piping is your inlet and your outlet. There is also an optional vent. As the reactions do occur, there can be some byproducts or off-gassing, and it's wise to vent those so you're not creating a hazardous condition within the tank. So that would be an optional vent. And again, those can be placed at various locations without geometry of the tank. And again, those are all stainless steel hardwares there. I mentioned, I think earlier, that the joining method to a tank has to be mechanical. Because the tanks and the piping used here are high-density polyethylene, polyethylene and polypropylene will not bond to each other during a fusion bond. And so you would either need to use the mechanical groove, the stab lock, or a threaded connection, male or female, to make the connection to the tank. So if you look at the step-by-step, you'll see that the inlet pipe actually bends down and goes to the bottom of the tank. Imagine that filled 3/4 of the way with limestone. As that effluent is filtering up through that, that's the retention time where it's being treated before it does exit the tank through the outlet. And so while that's going on, that material is being neutralized, and hence the name, neutralization tank. So the fluid enters, filters up through the rock, and then is discharged out the outlet. So if we take a break here to do a test your knowledge on how well you're paying attention, we place the following in the correct order. A, fluid passes through limestone chips to neutralize alkaline waste. B, wastewater is discharged to the sewer system. C, the inlet channels chemical waste directly to the bottom of the HDPE tank. Pretty simple process here. The correct order is C. Waste enters the tank, channel to the bottom. A, the fluid passes through the limestone, and then B, finally, the wastewater is discharged to the sewer system. So here we go with the limestone. We do sell those in 50-pound bags. There is a chart in the catalog and also shown here how many pounds of limestone typically fit within a tank. You can see 50 pounds in a 5-gallon. In a 500-gallon would be 5,000 pounds, and you know, everything in between. Again, the limestone is 1 to 3 inches in size. You don't want it too small or pea gravel because you won't get the water to flow through it. And if it's too large, it doesn't have enough surface area to do the neutralization. So keep it within the 1 to 3 inch size. And then the other strict requirement is that there must be a 90% or greater calcium carbonate content within that limestone to be able to create that neutralization. And then the replacement chips are required, so the rock is used up and does react. And I'll talk to you about how you know that here in a slide or two coming up. So again, we've got a palette shown there. One other feature of our system is we offer the fixed cartridge. So this is more of a point of use. So if you imagine this being underneath the lavatory outlet, kind of like a garbage disposer in your home, it's going to treat the waste immediately upon entering of the sink. The nice thing about this is that if it's a retrofit or a facility that hadn't been purposed for a laboratory, it can be retrofitted fairly easily by use of the fixed cartridge. And again, just as the neutralization tank filters the waste through the bottom so that it filters up through the media, same mechanical process here with the fixed cartridge. However, we don't have huge amounts of limestone. We've got a very different proprietary blend here of material that does that same neutralization on a much smaller scale. It actually does last longer and is more effective, but it does cost a lot more. So you would ask, why don't we use this media in our big tanks? And the reason is cost, and this sizing here is also maxes out at 10 gallons per minute. So if you've got a typical faucet aerator, that would be used in a laboratory, say of 2.2 gallons per minute, you could actually hook up 2 waste lines to 1 cartridge. Typically, to be safe, you're going to go 1 per each outlet. But again, can be used also in new construction. It's ideal for retrofit, but there's no reason that it cannot be used in new construction too. Again, depending on the facility, the engineer is going to specify either a complete system with a neutralization central unit or point-of-use fixed cartridges shown. So how do you know that the waste you're expelling is the code? And we do offer a pH monitoring system. So what that installation would look like is after your tank, let's say you've got a 300 or 500 gallon neutralization tank, you would feed into a sampling tank. So a 5-gallon tank that would have a pH probe in it, and that is going to record the pH of your effluent. So these can be set to a high and low alarm, and should they go off, know that you'll need some maintenance of your tank. So again, you've got to be careful on the discharge side not to have any waste that's too acidic or too basic, which then can corrode the municipal piping. And so, again, depending on various codes, there are requirements of a high and a low pH, and so these recorders are going to help you maintain compliance and also give you an indication of when to change your limestone. So if you look at the overall kind of features and benefits question is, do you need a dependable method for disposing of chemical waste? If the answer is yes, then we've got a solution for you. Again, a multi-tiered, cost-effective solution, pipe options, and then different joining methods to suit your needs. The fittings do provide you leak-free, quick installation, and a system that's good for the life of the building. And the next question is, do you want to be ensured your piping is chemically resistant? Certainly there are alternate piping systems out there. Some of them are more susceptible to various chemicals. And if it's a building that might be a lab today, more in-depth one tomorrow, and you really aren't able to change piping, you want to go with the best solution and offer the best chemical resistance. Again, if it's a building that's already piped, typically you don't repipe it. You could go with the fixed cartridge system. Again, not only do we offer the various pipe fittings, connections, the cleanouts, the tanks, and the monitoring system to really provide a complete solution. So our applications engineering team can help guide from sizing. Again, you're going to have a minimum retention time within that tank to ensure that the waste is been treated, and then monitor it. So we've got another question here, and what are the top 3 benefits of the Zurn drain? A, dependable leak-free waste removal. B, highly durable chemical resistance. C, patented stab lock fusion or mechanical joining method. Or D, customizable neutralization tank. Meanwhile, just to highlight the polyvinylidene fluoride FD2 photo shown on the left here, again with a stainless steel drain top and a reversible clamping collar and stainless steel hardware. And you can also see the outlet there for the optional trap primer connection. One thing to note with the PVDF drains, as I mentioned, you cannot glue them, and therefore we've got a pipe stub already stick welded or fabricated into that body outlet for you to be able to join to your coupling. And with the PVDF, it is a mechanical fitting. All right, let's go ahead over the answer here. And if we look at the drainage system, I would say that your top 3 are going to be A, B, and D, while C gives you the optional joining methods. Your critical components are going to be your leak-free handling of waste, chemical resistance, and then that system treatment at the end for your neutralization tank. So just a real quick summary for the various customers we serve. The building owner, a dependable leak-free waste removal system that's watertight, durable, chemical resistant for the life of the building. From the engineer standpoint, a wide variety of the chemical resistant materials to choose from to optimize the cost of the system. Customizable tanks depending on the gallons per minute of effluent. And then also the chemical resistance, knowing that your system is going to be in place for the life of the building. From a contractor standpoint, you've got your leak-free joints, your fast installation with the stab lock, and with the various joining methods available with the same fitting, you've got your job site flexibility, minimizing any type of multiple duplicate inventory you need to carry on site. Just a Zurn overview. Again, for over 100 years, Zurn has provided leadership within the manufacturing market for plumbing, commercial systems and solutions within water technology, water handling. Definitely an innovative leader in those lines, and provide solutions just beyond the product. Any of our application engineering teams or local representatives are there to serve and help provide answers. So, got one choice, one Zurn, and want to be your choice. Just a quick resources and support there with our address, the 8551 Zurn, and then the online sources as well. And again, if you've got more specifics, please contact our applications engineering, and they'd be happy to give you a little bit more, detailed drawing or layout.